In this video, we are going to take each angle given in radians, and we are going to find a coterminal angle between 0 and 2 pi. We'll make a sketch. Of course, we'll figure out what quadrant it's in, or maybe it's on the x or y axis. And finally, we will find a reference angle in radians. Alright, for number one, I'm actually going to start with the sketch. So here's a quick unit circle that I will draw. So I'm noticing that we're talking about pi over 4s. So I'm going to go ahead and divide this up into pi over 4s. Alright, of course pi is a semicircle. So I've divided each semicircle up into 4 pieces. So these are pi over 4. So the initial side is always the positive x-axis like this. This is negative, so we need to go in the clockwise direction. So this would be negative 1, 2, 3, 4, 5 pi over 4 would land right here. So this will be my terminal side right here. Okay, so this is a sketch of negative 5 pi over 4. Notice that we are in the second quadrant, so go ahead and get that out of the way. And we can also talk about the reference angle. Each one of these is pi over 4, including this, which would be the reference angle. Reference angle is always positive, so that's going to be, of course, pi over 4. So that just leaves coterminal angles. Now, if I go in the positive direction, if I just went from here to here, that would be 1, 2, 3 pi over 4, so that would be a coterminal angle. But you know what, let me just do it mathematically. You know that I can get a coterminal angle if I add or subtract 2 pi. We need like denominators though, so 2 pi over 1, if I were to multiply by 4 in the numerator and denominator, that would be 8 pi over 4. So if I want coterminal angles, I can just add and subtract 8 pi over 4. So if I take negative 5 pi over 4 and add 8 pi over 4, then that's going to give me the 3 pi over 4. Okay, so that is a coterminal angle between 0 and 2 pi. Alright, that is this angle right here, 3 pi over 4. Okay, so that's it for problem number 1. Now, looking at problem number 2. Again, I would like to start with a sketch. It would be helpful to know what this is as a decimal, 13 over 10. Of course, 13 divided by 10 is 1.3. So this is the same thing as having 1.3 pi. Now, let's talk about what quadrant that would be in. Okay, so this would be pi. If I'm going in this direction, the positive direction, pi would be right here, and this would be 1.5 pi. Alright, 1.5 pi if I went to here. So 1.3 pi is going to be somewhere here in the third quadrant. Okay, so let's go ahead and just draw that. Okay, so here is the initial side, which is always the positive x-axis, and the terminal side is going to be somewhere here in the third quadrant. Okay, so this is part of my drawing. So that is a sketch of 13 pi over 10. Now that is between 0 and 2 pi already. So there is no other coterminal angle that's going to be between 0 and 2 pi. So I'm just going to recopy the angle itself. 13 pi over 10 is the only angle, the only coterminal angle that would be between 0 and 2 pi. Okay, so let's just put that down. Now, we are in the third quadrant, so I can go ahead and record that. And that just leaves the reference angle. Now, the reference angle is this angle right here, between the x-axis and the terminal side. So we can find that by doing a subtraction problem. Right here is pi, and the angle itself is at 13 pi over 10. So my reference angle is between these two. So you can just find that by subtracting 13 pi over 10 minus pi. Okay, now I need like denominators, so I could look at pi as 10 pi over 10. So 13 pi over 10 minus 10 pi over 10 is going to be 3 pi over 10. So that is the reference angle. Let's do one more. I see we have negative pi over 6. Whenever I see that we have a special angle, alright, that's one of the ones that we have memorized, then I want to draw it on a unit circle. So here is my unit circle. And I'm going to go ahead and divide it up into pi over 6's. Okay, so you can see each semicircle has 6 parts. So they are each pi over 6. So one more time, my initial side is always the positive x-axis. And now my terminal side, we're supposed to go negative pi over 6. So I'm moving clockwise 1 pi over 6. So that's just going to put me right here. And I need to draw the pathway for negative pi over 6 would be like this. That is part of the picture. It is necessary. Okay, so there is my sketch. Now, I'm supposed to say a coterminal angle, and imagine that I went the positive way around instead of going negative. If I went the other way around. Now, if I go all the way around, if I go halfway around, that's 6 pi over 6. If I went all the way around, that's 12 pi over 6. So I'm stopping short by 1, so that's going to be 11 pi over 6. Of course, I could sit here and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 would also work. So I just wanted you to see sort of the common sense of what I'm doing, that it should be 11 pi over 6 should be the coterminal angle. Now I could get that just by addition. I can find a coterminal angle by adding 2 pi, and if I want a denominator of 6, then I would have to multiply by 6. So this would be like having negative 1 pi over 6 plus 12 pi over 6, which of course is the 11 pi over 6 that I just spoke about. Okay, so that is the coterminal angle between 0 and 2 pi. And this is the sketch. Of course, here we are in the fourth quadrant. So let's name that. And the reference angle is simply going to be pi over 6. You can see in the drawing that each one of these sectors, each one of these angles is pi over 6, including this one. This would be the reference angle right here. It just has to be positive is all. And that's going to do it for this video. I hope it was helpful. I will see you on the next video.